Okay, so the secret here is, so you see this counter, right? 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 So you use contaminated gloves to touch the light switch. Right? But the other thing I'm going to teach you, call this, the other thing I'm going to teach you, some of you already know how to do this. How are you supposed to take off gloves? Does everybody in this room know how? Everybody does? So what do? I'm going to grab what? This right here, right? And then what I could do is I could take my finger and reach in. Whoops, that's the wrong way to do it. Cheap shit gloves. Now, I'm going to wad this one all the way up in this hand, right? Take this finger and do what? Go on the inside, right? Now this entire thing is here, right? Until it breaks. Well, I use nitrile gloves. So then the secret here, I'll turn this off. Check if I did it right. Look where the glove ripped. See that? See it right there? So look at that. Get that off of there. Oh, look at that. So you guys did a you guys did an experiment on today, this afternoon, right? Where you put a piece of candy in your hand and shook hands. I hate that experiment. So I use this cup called glow germ. We're going to do the same experiment, but we're going to use this fish food. Isn't that cool? It's like luminol. Well, it's not like luminol. I should tell all my colleagues that this is luminol. And leave fingerprints all over the class. Let me turn this stuff on again. So we're going to finish 13. We're going to do 20. What? 27. And then we're going to start 14. Is that getting caught up or no? What am I supposed to do today? Okay, I'll do everything today then. I'm supposed to do 15 today? Is this 20th? Really? No movie day for us this semester. Can't get behind. Actually, didn't promise. I don't have any independent recollection of those events. They're not credible witnesses.
You said if you have to skip a test, you will.
Remember the credible witness thing we talked about? Page 13 should be real quick. So 2 slides. Right? A friend of mine who we were drinking and he went to his hotel room and he passed out. And he woke up and he's covered in brown stuff. He told me that he smelled it, they tasted it. chocolate that they left on the pillow. I said, dude, you would really taste that? All right, ready? I know that it says prevalence first in your PowerPoint, but let's switch it around. Okay, so this is incidence is the measurement of new cases over a time period. So we want to know what's the incidence of the number of cases in the last week or the last month. We would never say what is the incidence of Ebola in the United States. We would never say that. We would always have to add a time period. How many new cases last week or the last month? And the way you typically do this is you take the total number of new cases divided by the number of people susceptible to the disease. So you know what this means? This means that people who already have the disease cannot be included in here, right? And people that aren't susceptible to a specific disease. For instance, if you talked about diseases that affect only the very young, the very old, or the very sick, then those people would not be included here. It's only the susceptible population. If you were going to discuss, for instance, measles, you would not include people who have been vaccinated. You would have this discussion regarding unvaccinated population. So this is going to tell you the number of new cases every week, and this is going to tell you how rapidly the disease is spreading. Now remember, the World Health Organization says, so how many cases are there? 8,457, 453 or something like that, right? So far? So the World Health Organization is saying that there's going to be 10,000 new cases per week at the end of this year. And they're trying to forecast this number right here. Do you think that that tells you that the disease is spreading quite a bit when you think of 10,000 new cases per week? The other number, of course, and this is reported per 100,000 people. Prevalence, however, is telling you what the risk of infection in the population is. For instance, this is just a straight out question. How many people in the United States have influenza? How many people in Botswana have malaria? How many people in Nigeria have Ebola? Does anybody know the answer to that last question? Zero. Yeah. Yep. So this is reported as a percentage of the entire population. Whenever they talk about obesity, or they talk about high blood pressure, they typically talk about prevalence. And how prevalent is a disease in a population. Okay, here's the next one. You have this one. Did I cover this one already? No, I didn't. I stopped here. I think I stopped and told you that anytime the prevalence of any disease exceeds the expected or the endemic level, then that's an epidemic. For instance, if I told you that, I think I said this before, how prevalent is malaria in the United States? Well, 0% of the population has malaria. How many cases would we need in order for that to be an epidemic? Just one. Or to be a little bit more, something that's probably a little bit more appropriate, would be influenza. If every year we have 18% of the population getting influenza, anytime we exceed that number, they would consider that an epidemic. Love's laying on the floor, kind of creeping up. I should reread that for our next teacher. Okay, two types of epidemics. So this common source epidemic is when large numbers of people are infected from the same source, right? Everybody drinks from a contaminated water supply. We see how that would be called a common source epidemic. Okay, a propagated epidemic, when we have the disease moving from person to person like influenza. My next question for you. Sexually transmitted disease. Is it a common source epidemic or a propagated epidemic? How many say propagated? Anybody say common source? Now what if it's 9 individuals having sex with 1 individual? I don't mean at the same time. Right? So you guys all know that a pandemic is, there's many phases of pandemic, you don't need to know those phases, but a pandemic is when we spread across continents or multiple regions. The source is where you got the infection. The source can be a person, most likely it's a person, but the source could also be a fomite. Reservoir is where the primary habitat is for the organism. So somebody asked me the other day, could we eradicate Ebola? You guys remember the reservoir for Ebola? What is it?
It's a river in there.
Fruit bats. Ebola is the name of a river in Zaire, true. That's where the name, or one of the 4 different strains of this virus has come from.
But it came from bats originally.
So the reservoir, where it hides right now, let's say that there's no Ebola in the human population at all. So where could the organism be found? And why couldn't we go eradicate it? Well, you'd have to kill all the bats. What you'd have to do is, I said that you'd have to basically find every single cave, and you'd have to close off the entrance of the cave and close off all of the entrances of the cave, and then pipe some gas in there, killing all the bats. But the problem is, too, is that you understand that even though you have dead bats, you can still have viruses that could remain viable for a long period of time in the corpses of these bats. Maybe it's 3 days, maybe it's 20 days, maybe it's 30 days, 90 days, whatever it may be. So then you'd have to grind up all these bats, and you'd have to cover them with bleach, and you'd have to be quite a thing. So, and one of the things I'm going to remind you too is that the prediction is that Ebola is never going to leave the human population at this point. They say it's going to stay in the human population and be ongoing. It doesn't mean that it's going to be ongoing in terms of a sharp increase in the number of people. At some point it will reach equilibrium, but they say that there's always going to be people that are infected with Ebola from this point forward, because it's the largest outbreak since the last 3 outbreaks.
But wasn't there always people?
No. No, there were 3 outbreaks, and in between each outbreak, there were no humans that were ever infected in between each of the outbreaks. There was even an outbreak in the United States. I told you guys about the rest of the strain. But it wasn't among people, it was among primates. And 2 handlers got bit, tested positive, but they didn't die. It's a strain that doesn't kill you. So for instance, the soil happens to be the reservoir for the tetanus, the organism that causes tetanus. So if you wanted to eradicate tetanus from the face of the planet, you'd have to get rid of all the soil. It would be good then. Cholera. Water is typically the reservoir. Can you name any organisms that we have eradicated? I haven't done shit. Okay. Can you name any organisms that really smart people with several PhDs have eradicated? Anybody can name an organism that's been eradicated? No? Never heard of smallpox? See, hardly any of you in this room have a smallpox vaccination, because it was eradicated in 1978 by David Henderson. He eradicated it because he found out that the reservoir was people. So if you want to eradicate an organism in the reservoir as people, what do you have to do? Kill all the people. Okay, well, we can't do that because a lot of people won't go along with something like that. So then what you could do is that you could vaccinate all the people. That way you could eliminate the reservoir and eliminate the organism. The day that David Henderson announced that he was eradicating smallpox, there were actually protesters that were at Johns Hopkins protesting because they say you don't have a right to commit genocide on an organism. There are people that will protest anything and everything. Watch, ready? There are people that are going to protest what I just did. There are people that protest just for the sake of protesting. All right. A zoonotic. This is the name for an organism or an infection that typically resides in animals but can be transmissible to humans. There are 150 zoonotics existing worldwide. Rabies is one, right? Anthrax is another one. Salmonella is another. Those are called zoonotics. There's another one called the avian or bird flu, transmissible from birds to humans, but not human to human. When that virus does mutate and it goes human to human, we're going to have an avian flu pandemic. I guarantee you. This next slide you don't have. You are going to be tested on this. It's called the basic reproductive rate, because if we talk about incidence, prevalence, epidemic, pandemic, these words that are used in epidemiology, I want you to know this calculation called the basic reproductive rate, R of 0. I actually have a friend that I went to school with in public health, and his name was Roe. And we would always call him R of 0, and after a while he'd get upset. Stop calling me that. R of 0, R of 0. So R of 0 is defined as the number of new cases that will emerge from one infected case. So the idea being that if one person in this room gets Ebola, how many new cases will we expect from that one case? I also want to show you this next thing as a reminder that each new infected case then generates new cases based on this number. So for instance, if Jenny had Ebola, don't take it personally, if Jenny had Ebola, we would expect that, say, 4 new people in this room, there'd be 4 new cases. So let's say there's 4 random cases in this room that get it from Jenny. Does everybody understand that each of those cases would generate 4 cases of their own? So do you see how this number is a pretty significant calculation to learn and understand? So in the School of Epidemiology and Public Health, they teach you that R of 0 less than 1 means that the infection will typically subside and then cease. Example, what will happen a lot of times with influenza is that you'll have a number that will then get smaller and smaller, and then it will get less than 1, and then the flu season is over. And then that infection ceases. And the next time flu season comes around, it's probably going to be a different organism. If R of 0 is greater than 1, that means that the infection will spread in the population and continue to spread until it reaches equilibrium. Therefore, larger R0 values means that it's more difficult to control an epidemic. Smaller values are easy to control in terms of an epidemic. Here's some examples. Measles has an R0 factor of 18. It's the most communicable disease that I'm going to teach you in this class. By the way, I did not sort these by mortality, did I? I sorted them by how infectious they are. So measles, basically, the calculated rate is that for every 1 person that gets the disease, 18 people are going to emerge, 18 new cases will emerge from that 1 person. And then 18 more from each of them. So you guys know what pertussis is. What's the other name for that disease?
Whooping cough.
Whooping cough. Highly communicable. And then these 3 sevens here, diphtheria, smallpox, and polio, have a reproductive rate of 7. HIV has a reproductive rate of 5. SARS, also 5. Influenza, 3. And Ebola, 4. Could you imagine if this number was that? Right? So you're looking at this and you're thinking, well, I would have expected this just to be off the charts and scare the shit out of me. But the reason this number doesn't scare you, it's the other number that scares you. The mortality rate. The mortality rate for pertussis is extremely low. Very, 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 very low. all of these diseases, the mortality rate of Ebola is extremely high. The first two outbreaks in Africa had an 88 and 90% mortality rate. I know that right now you got a calculation of around 70%. That's because the song isn't over yet. I don't want to go over there and rain on their parade, but there's more people that are going to die, obviously.
So for every 1 person infected, 4 people infected with Ebola.
Yes, based on how likely it is and based on its mode of transmission. Based on a couple of other things. Measles has an infectious dose of what? Does anybody remember? 1 virion. 1 particle. So do you see how infectious it is? Okay. Tuberculosis should be up here. I should gather the data for TB and put it up here. So Ebola, that means exactly 4 people. Based on bodily fluids and the size of the particle and how it's transmitted. Okay. Don't be surprised if this number changes. It might change and get smaller, or it could get larger. Do you agree that these numbers are based also on the habits of people? How many times they touch their face? How many times they touch fomites and don't wash their hands? Right? So I think that's the end of this, right? You have to do 27. There isn't. You know why? Because there's only 2 questions from that chapter. I'm going to go extremely fast. And all you have to do is write 2 sentences. And you'll have all you need to know about that chapter. Is that going to be okay for you guys? Yes, I know a lot of you guys want to print out that PowerPoint instead. Can I borrow this? Use your portable inkjet printer right here, okay? There it is. Now that's going to go in the dark, right? I had a professor once that helped design organisms that would eat oil. Why would that be handy? That's exactly, right? Oil spills. Let's get these up because I think I might do that. I'm going to tie a knot in this end. These are cheap ones. These are the ones that I give to my wife. She wears them under her gardening gloves. Gardening. I'll tell you what she does when we go to the hospital. She rolls down the window when I'm running inside. Don't forget to get gloves. So we're going to exploit fermentation. We can use fermentation to produce some enzymes and chemicals that we can use. So we're going to use biotechnology, and a lot of times use biotechnology and microbes to help make some of these products. In food science, medicine, agriculture, environmental protection. Some examples here. Bread. You guys have seen that you can purchase yeast in little packets at Vons, correct? Or at Browse. Because what does yeast do? It helps what? Helps to build rise.
It traps carbon dioxide.
So it helps to build rise. Agreed? Wine, of course, we can ferment fruit juices. So if we're talking about fermentation, do you agree that we have to use, most likely, eukaryotes? And we have to deprive them of oxygen so that they can take an alternate metabolic pathway, right? And so, for instance, wine, we're going to ferment the fruit juices because we need to have a source of sugar, correct? So if we take yeast and sugar and put it together, what are the 2 products going to be? The waste products? Alcohol and what else? The first one's in the first sentence there. CO2 and alcohol, agreed? Those are the 2 waste products when yeast ferment sugars. We could do all this in the toilet in the prison, right? What's it called? Nobody wants to admit that they know the name of it. Anybody tried it? Bruno. Carol says that stuff will take your ass. I said, oh, have you tried it? She says, yeah, when she's hanging with her exercise yard peeps. So what they do is they take garbage. They take all of the compost, fruits and vegetables and stuff that will degrade. You put yeast in there, put it in a plastic bag, put it in the toilet. It ferments all the garbage. It makes what? Alcohol and CO2. At least I got something to look forward to. Vinegar is the fermentation of plant juices. You can also make vinegar by taking wine and letting bacteria in there. And the bacteria will cause a secondary fermentation and turn wine into vinegar. That's the only reason why you taste wine at the dinner table. You don't taste it and say, oh, you know something, I don't really like this. Can I send it back? No, the cork is out of it and you're paying for it. You're tasting it for only one reason, to make sure it hasn't turned into vinegar. Agreed? Right? You can't just send it back if you don't like it. Especially with an $800 DRC, right? Okay. Vegetable products like sauerkraut and pickles are made through the fermentation process. Also, milk and dairy products, cheeses and yogurt are made also through the fermentation process. Some of them with eukaryotes, some of them with bacteria. Have I missed anything? So I got everything that's made by fermentation, right? Haven't missed anything, huh? Gee, you guys are obviously not bringing your thinking to school today. So we can also make beer. Let's go back. Yes, same company. Yes, the same company that came out with the Guinness Book of World Records. Same family. There was a family member that was bored and had shitloads of money. Said, hey, I'm just going to travel around the world and have people do stupid stuff and put it into the Guinness Book of World Records. Same family. Another thing you should know about this company. You ever go to Dublin, which is where they make it, you walk into the factory, you get a tour. You walk into the factory and laminated into the floor is the lease. Now the land is approximately the size of either USC or UCLA's campus. That's how big their facility is. And they leased that land. Are you guys ready for this? In 1759, they signed a 9,000-year lease for $154 a year. And the guy, the family, the estate says, you know, if you want, you know, we can cut this lease, cut you out of this lease if you want to buy this. He said, no, here's your $151. We'll see you in 1 year. I know, and that includes the water and mineral rights. Oh yeah, oh yeah. Okay, so one of the things that you'll also find in Ireland is they are very, very proud of these yeast stores. See, there's cake making supplies here, right? So they have these strains of yeast that have been around for a long time. It's not one organism that's been living that long. It's a continuation of the colonies of yeast. And they use it in cake making, bread making, and wine making, and beer making. You don't see stuff like this too often in the United States. So let's talk to you about how to make beer. You guys ready? The first thing you have to do is called malting. You take barley and it gets sprouted and softened. And you see that's going to be the source of your sugar. Don't you agree you have to have something for the yeast to eat, correct? So there's your source of sugar. You're going to take that malt and you're going to grind it up and soak it in warm water and heat it to around 60 to 75 degrees. Notice you haven't added the yeast yet. The next thing you're going to do is you're going to add hops to this mixture. And this now is going to be called wort. And hops extracts bitter acids and resins. Because wine can be pretty bitter. I mean, beer can be pretty bitter if you just ferment barley and drink it. So they add hops to it to take away that bitterness. Now after that's done, they add the yeast. Saccharomyces cerevisiae. So this is a very common yeast that's used in the food industry. When they add this yeast, again, what are the two waste products going to be? Alcohol and CO2, right? So here's where they're going to add the hops. Now they're going to add the yeast, and you know what they're going to have to do eventually? They're going to have to cap this and this so the CO2 doesn't escape, right? What I'm going to do is I'm going to lay down right here. Next, they're going to age it and finish it. And that's how they're going to get their beer. Can anybody tell me about this equation here? What is this first thing right here? Sugar. What is this right here? What is this? Take a guess what this is. Alcohol. And that equation is balanced to show you that we're not making up the fact that alcohol and CO2 comes from sugar. So this is hops. This is the facility that I have in my basement. When you go on the tour, what they do is they give you Guinness on every floor. When you walk in, they've got this big table, and you just grab one and you drink it, and they give you different types of Guinness that you don't get here in the United States. There are some types of beers that they send to Europe, and some to all around Africa, some Northern Africa, some stay in Ireland, a few of them come to the United States. They just advertise what a Guinness Blonde, right? We'll see. I'll try it. I'm not going to promise anything. So, and you go to this restaurant at the top. It's a restaurant that has a 360-degree view. You can see all of Dublin, and they give you more Guinness. And even give you hamburgers that are made with Guinness. And at the end of the tour,
Were you begging to open
slam the
gate?
door in your face. Yeah. Next, we should talk about wine. What are we going to use as our sugar? So we're going to take the pips, the leaves, and the stems. So we're going to remove those during the harvest. And then we're going to press these grapes. What did the grapes say when it got pressed? Nothing, it just let out a little wine, right? So the grapes are placed in the press, they extract the juices. Let me ask you a question. Here's a true or false question. You ready? Red juice comes from red grapes. White juice comes from white grapes. True or false?
True.
All the juice from all the grapes is clear. It is clear from every grape, whether the grape is dark red, white, green, yellow, the juices are always clear. What makes your red wine red is because they let the skins stay in contact with the juice for a little while so that those tannins and those flavors from the skins of the grape can permeate the juice. But you could just press. It's called a white Zinfandel or a Sauvignon Blanc. They just press the juice and don't let the skin stay in touch with the juice. Drain the juices off very quickly, and you have juice that's clear or yellow colored.
My mom has a grape garden in Ukraine, and when she presses those black grapes, the juice is done.
Yeah, but what grapes are they? What grapes are they? They're not the grapes that we're buying here. They're not Sauvignon grapes, or they're not
No.
Zinfandel grapes. They're not, Chardonnay grapes.
No, she still makes wine out of it.
I'm sure that there's 256 shades of gray, so there are berries and grapes that you could squeeze and get some kind of dark juice out of,
Right.
but not the juices that we typically make.
Okay,
in
you're
wines.
talking about wine.
So, and